So follow along here and let's see if we can get all these correct. Okay, so number one, we're looking at the cube root of 3x to the fifth, and our goal here is to write it in exponential form. Okay, so remember our exponential form, if we have something like this, x to the a over b, we can convert that to radical. It would be that b is the index and a is the power. So we can go from here to here and vice versa. So we want to go change this into radical form. Now, I don't have a single exponent here, I just got the 5 there. So I can put that 3x to the fifth in a parenthesis of its own and then raise it to the 1/3 power. That would take care of my cube root. Okay, and that would be enough to put it in exponential form. If we wanted to split it up a little bit more, then we could do it like this, where we give that cube root to both, or that 1/3 power to both of those. So it'll be 3 to the 1/3, x to the 5/3. And then that would be our expanded exponential form, I suppose. Okay, so number 2, same thing, we have this square root over everything. So that means we need to put everything in parentheses, like this. And then a square root is the same thing as a 1/2 exponent. Okay, so there's a little 2 that's implied there. We don't usually write it there just because it's implied, kind of like the 1 in front of an x sometimes. Okay, so now we're going the other way. We're going to write it in radical form. So I have here, I got x to the 3/5. So the bottom is the index, and the top is the power. So it would be a 5th root of x cubed. That's how we would write that one. And then over here, we got the 3/4 power. So 4 is my index, and then I have 3 n to the 4th j. All of that on the inside is being cubed. Okay, that would be sufficient. We could, if we wanted to, take that that exponent and give it to everything. So it would be this. So 3 cubed is 27. And then n to the 4th cubed is n to the 12th because we multiply our exponents. And then we have j to the 3rd power. So either one of those would work. This one right here is a little bit cleaner than the original, or than the other one. Okay? So down to the i's, using complex numbers here. So for each imaginary number, indicate whether its value is I, -1, -I, or just a 1. So we have I to the 38th here. So you want to figure out what number closest to 38 is divisible by 4. Because remember, I to the 4th is just a 1. So every time we have an I to the 4th, it's just going to cancel out and go away. Okay, because 1 times anything is itself. So if we got I to the 38th, we know that I to the 36th power is divisible by 4. So that would just be a whole bunch of 1. That would be 9 ones there. So it would be 1 times 1 times 1 times 1 times 1, 9 times. Okay, but we started with I to the 38th, so we also need an I squared, because that would maintain the problem. So these are just going to go turn into a 1, and then the I squared is a -1. Right, because I times I is I squared. That would be a square root of -1 times the square root of -1, which is -1. Okay, so number 6 over here, we have I to the 63rd power. So I know that I to the 60th power is divisible by 4 evenly. So then that means I must have I to the 3rd left over. Okay, that's going to turn into a 1. So I got I to the 3rd. And we got to remember what I to the 3rd is, because we want to simplify this down to one of these. This up here doesn't say we can leave it as I to the 3rd. So I know that this is I squared times an I. Well, this right here is a -1. So I cubed, remember, is -I. That's what it simplifies down to. Okay, and now we got some radicals down here below. So number 7, we want to simplify square root of 75. So if we don't have a perfect square, we got to factor tree it. So it'll be 5 and 15, and 15 breaks down into 5 and 3. Since it's a square root, we're looking for 2 of a number. So we have two 5s, which would give us a 5 in front. So it would be 5 square root of 3. That's what that would simplify down to. Okay, so we're going on to number 8 now. So we're looking for cube root of 8x to the 5th, y to the 8th. Well, I know that the cube root of 8 is just a 2. Okay, and then we're looking to take out groups of x's and y's. So we have 5 of those x's underneath there, like this. So remember, every time we get 2 of those, that gives us an x in front of the radical. So that would be x squared in front of the radical with an x left underneath there. And then the same thing with the y to the 8th. Okay, and actually we are doing a cube root here, so I made a mistake. So let's fix that. We're looking for 3 of a number. Okay, I had it right to begin with and I started messing up. So cube root of 8 is a 2, looking for 3 of a number. So we got to circle 3 of those, not 2 of those. Okay, so that'll give us just a single x in front. And then that's going to give us an x squared underneath. Okay, so make sure you're paying attention to the difference between a square root and a cube root. Okay, I've seen us do that so far, and I just did it. It's kind of easy. Make sure you're double checking things. So I got y to the 8th next. So I can take 2 groups from that. That'll give me a y squared, which would take 6 of those away. So we have a y squared underneath. And I got to make sure I put my little 3 back in there, that index number. All right, that's what it simplifies down to. Next one, number 9. So we have a distributive property type problem here. We're going to take that square root 3x and take it into both of those. So we're taking a square root times a square root. You're just going to multiply whatever is underneath the radical. So for the first one, I'm going to multiply 3x and 12x, which is going to give me 36x squared. And then I have a minus there. 20 times 3x is square root of 60x. And then I know that the square root of 36x squared right there, that's just 6x. Okay, I got to put my 60x here. This is just 6x. And then we got to break that 60 down. So let's do 2, 30, 2, 15. And I know that that 15 is just going to be a 3 and a 5, so I can take my 2's right here. So it'll be minus 2 square root 15x. And remember, we cannot do anything else from there because we have to have exactly the same radical in order to add or subtract anything. We can't put anything together there. And when we simplify this down, remember that we can change this to exponential form to make it a little bit better, and that'll kind of get rid of our radical. So we have a 5th root and a 15th power. So we do power over index. So it'll be 2ab to the 4th, c to the 6th. And my power is 15, my index is 5. So then we can simplify that down from there, 15 over 5 to the 3. So since it's a cube, we would distribute the 3 into everything. All right, we got 4 things in there, or you can write it out 3 times and see what you get. Okay, so we want to do 2 to the 3rd power, which is 8. And then we have a to the 3rd power, b to the 12th, because we multiply exponents, and then c to the 18th. That's what that one would simplify down to. Okay, so first you want to change it to exponential form, and then you can simplify it down from there. On number 11, we have a square root. So remember, you could split it up right away and rationalize it. However, I would look and see if it divides first. Does it divide inside of the square root first? So 32 does have a 2 divide out of it. So 32 divided by 2 is 16. And then the x's, we're going to have 2 of those cancel out. So we'd have x to the 6th on the bottom. And then we're going to have 1 of those y's cancel out. So we have y to the 4th on top. And then we have the square root of that. So we have the square root of a fraction. Remember, we can split that up. All right? So square root of 16 y to the 4th over square root of x to the 6th. And we can break that down. So square root of 16 is 4. And then y to the 4th, we can take 2 groups out of that, 2 groups of y squared out of there. Okay, so we would just get that. And then x to the 6th, we can get 3 groups from there. Okay, so that would be x to the 3rd. And then that's what we have. For 15, actually we'll go down to 11, or 12 here, excuse me. So we'll kind of work 12, then it'll bounce up to 15. So 12, we got a square, so we're going to have 4 minus square root of x squared, so we have to write that out twice, and then we FOIL it out. Okay? So 4 times 4, 16. 4 times the negative square root of x is negative 4 square root x. And then we have another negative 4 square root x. And then the last one here, square root of x times the square root of x. That would just be an x, and a negative times a negative is positive, so a plus x. And then we just gotta simplify it a little bit more. So I'm gonna put that x way in front. We have x plus 16 minus 8 square root x. And I'm not going to be super picky how we simplify or how we write it out, but that's the best way to do it. And we just simplify those radicals right here. 15, we have a negative 81 to the 5/4. So whenever we have a rational exponent, or a fractional exponent rather, we would change it to radical form if we can use that to simplify. Okay, and that 5 can go underneath the radical like that, or it can go on the outside. I would put it on the outside to simplify it. Okay, 4th root of a negative 81, so that negative comes out front as an I, and then the 4th root of 81 is a 3. Okay, so square root or 4th root of negative 81 would be a 3i, but I have 3i to the 5th. So we have to take 3 times 3 times 3 times 3 times 3. That's 243. Okay, it goes to both of those. Then we have I to the 5th. Then we have to simplify that I down. Okay, we know that I to the 4th is a 1, so let's just take out 4 of those. We've got 243I left. That's what it simplifies down to. So remember, I to the 4th is just a 1. So this is the way that was simplified down. I to the 4th comes out of there, and I have just an I left. So I have 243I. 16, we are taking the square root of something squared. So we can change that to a fractional exponent if we want to. Okay, it would look like this. Oops, 4b cubed. And it's power over index. The square root is a 2. Those would cancel out, and I would just have this left. Okay, I would simplify it down to that. Okay, let's scroll down here. Let's keep working on the ones down below. So number 13, you got to simplify everything before you can add them together. So the 12, that breaks down into a 2 and a 6 and a 2 and a 3. So we have a pair of 2's. So I make it a 2 square root 3 for that one, minus 2 square root 3 for the next one, because we didn't do anything with that one. And the 75, that's 5 and 15, 5 and 3. So that would be plus, if we take out those 5's, remember there's the 4 there. You got to take that times the 4 in front. So I'm bringing out a 5, and I got a 4 there already. So I would get 20 square root 3, because 5 times 4, that gives us a 20. Okay? And then, so these are going to cancel out. 2 square root 3 minus 2 square root 3, that's gone. And then we're just left with a 20 square root 3. Okay? 17, we are foiling radicals. So remember, we simplify first. So we got square root of negative 4 and square root of negative 16. Those are going to turn into i's. So 6 minus, that'll be a 2i. For the second one, when we simplify that down, we got 2 plus 4i. And then we have to FOIL everything out. Okay, so 6 times 2 is 12. 6 times 4i, that's a 24i. A negative 2i times a 2, that gives me a negative 4i. And then the last one is going to give us an I squared. We're going to have a negative 2 times a 4, it's a negative 8. And an I times I is I squared. So when we have our I squared there, remember that that is going to switch my sign because I squared equals a negative 1. So that would give me a positive 8 on the back end. So we can simplify from there. 12 plus 8 is 20. 24i minus 4i is a 20i. And that is done. For number 14, 3 minus square root 7 is in the denominator. That's the problem. So remember, we need to fix with conjugates. So conjugate of that would be 3 plus square root 7 on the bottom, and I also have to do it on the top. Okay, so there's going to be some distribution on the top, like this, and some foiling on the bottom. So 5 times 3 is 15 plus 5 square root 7. That's distributing in the top, and then the bottom, I'll FOIL it all out. So 3 times 3 is 9 plus 3 square root 7 minus 3 square root 7. And we have the square root of negative square root of 7 times 7, or square root of 7, sorry. That one times that one. That's going to give us a negative square root of 49, which would be a negative 7 down there. Okay, so simplify in the bottom. Those are going to cancel. We got 9 minus 7, so that's 2. And then the top does not change. So that right there is our solution. Similarly with number 18, we have i's in there. So we're going to have to use conjugates again. So 7 minus 2i on the bottom and 7 minus 2i on the top. So the top, let's FOIL that one out. So 5 times 7, 35. 5 times the negative 2i, so that's negative 10i. A negative I times 7, that's a negative 7i. And a negative I times negative 2i. It's going to give me a positive 2i squared. And then we need to simplify that down a little bit more, and I'll write it off to the side. So that would give me a negative 2 there. So 35 minus 2 is a 33. And then negative 10 and a negative 7 would give me a negative 17i. And then we need to FOIL out the bottom. So 7 times 7 is 49. Then we're going to have minus 14i plus 14i, and then minus 4i squared. So those cancel out. The minus 4i squared turns into a positive 4, because that I squared is a negative 1 again. So 49 plus 4 is 53. So we can't simplify that down anymore. 17 is prime, so we're done. I think 53 might be prime as well. For 19 here, this is the review problems, linear equations. So remember we had slope-intercept form, which is y equals mx plus b. We could use that. We also have point-slope form, which is y minus y1 equals mx minus x1. Okay, so we could use that. This is probably the one that I would use. And then we also have to have our slope formula. All right, that's slope formula. So we got to do a difference in the points. So that's the stuff that we need for this equation. Don't forget about it. This stuff comes up in every single class from probably 8th grade on. Okay, even in calculus, you graph lines every once in a while. So we're going to do y2 minus y1. So that's 9 minus 5 over x2 minus x1. 8 minus a negative 2. So double negative is a positive. 9 minus 5 is a 4. So we have 4/10. Simplify that down to 2/5. So that's our slope. And let's plug it into our point slope form, and then we'll pretty much be done. I'll show you what slope-intercept looks like just to compare. So y minus y1 is a 5 equals 2/5 times x minus x1. So that would turn to a plus 2. So this would be our slope, or a point slope form, x plus 2. That's the best way to write it. And remember, you can use either point here. You can use that one or that one, and it should be the same answer when we switch it to slope-intercept. So point slope is this one. Slope-intercept, we'd have to distribute to 2/5. So y minus 5 equals 2/5 x. 2/5 times 2, that would be a 4/5. And then we got to add 5 to both sides. So that's 5 over 1. Get a common denominator, which is a 5 on the bottom. So this would turn into 25/5. And then when we add those, we get 29/5. So y equals 2/5 x plus 29/5. That's your slope-intercept form. So if you went the slope-intercept route, that's what you should have. But either one of those would be acceptable because it just says find the equation. It doesn't specify which kind of equation. So that's number 19. Number 20 and on this page, these are all finding or simple solving equations here. So we got to get that by itself. Your goal is to isolate the radical, and then you can square both sides. So number one goal, isolate the radical. Add 4 to both sides. And then we get this. X plus 7. So now we have the radical by itself. Square both sides. Like that. So we have to FOIL the stuff on the right to stuff on the left. That square root and this square just cancel out. They're inverses. X squared minus 5 equals, this one FOILed is x squared plus 14x plus 49. So let's put everything to the right. So you can kind of see when I move the x squared over, that's just going to cancel out. So then we're just going to have an equation with an x in it. So we have to solve for x. So we'll have negative 5 equals 14x plus 49. So move the 49 over. We get a negative 54 equals 14x. Divide by 14, and then we got 54 over 14, which we can reduce that down to, we could take a 2 out of both of those, so it'll be a negative 27 over 7. Okay, and it says, remember to check your answers. This one is kind of not fun to check because plugging in a fraction is kind of a headache, so we're just going to kind of go with it for now. All right? For number 21 here, we need to solve the equation. The left-hand side, this is already, that square root's already isolated by itself, so we can just go ahead and square both sides right away. So square there, we get x squared plus 2x minus 8 equals x squared. And then we have to get everything on one side, or we can try to factor here. But if we look at moving this x squared over, just like in the last problem there, that's going to cancel out. And then we'll have 2x minus 8 equals 0. Then we've got to keep going from there. So add 8. We get 2x equals 8, divide by 2, and we get x equals 4. Okay? You can plug it in and check it. I know that it works, so I'm not going to spend time doing that. Okay, so down below here, we've got a few more problems left. So number 22, we have to isolate the larger of the radicals, which this one is it. It's already isolated, so we can go ahead and square both sides. Okay, when we square both sides, we're going to have to FOIL on the left. So square root of x plus 3 times square root of x plus 3. And then on the right, we're just going to have 3x plus 9. So foiling on the left, we do square root of x times square root of x, which is going to be an x. Square root of x times 3, so that's plus 3 square root x. And we have another plus 3 square root x. And then 3 times 3 on the back end is plus 9. Okay, so we'll keep writing that down and we'll simplify as we go. So that and that can be added together. So we have x plus 6 square root x plus 9 equals 3x plus 9. And now we got to put everything on one side away from that radical. Okay, we got to isolate the radical again. So move the x over, and then move the 9 over. Okay, so that's actually going to cancel over there. So we have this now. We have 6 square root x equals 3x minus x is a 2x. Divide by a 6. Square root x equals, so 2 over 6 is a 1/3. So we got 1/3 x. So the radical is now by itself. So we can take this and square both sides.
Garrett Coos, if you're still here, please go to the band room. Garrett Coos, go to the band room.
After we square both sides, that's going to get rid of my radical here. So I'm going to have x equals 1/9 x squared. Okay, and now this is going to be a little different than what we've seen before. So we have an x squared here and an x here. So that means we're going to have to factor. We got to put everything on one side. So we move this x over, and that cancels. Then we have 0 equals 1/9 x squared minus x. So we cannot put those two x's together there because one's squared and one's not. All right. So from here we got to factor. 0 equals, we can take out an x. 1/9 x, so if we take out that x, we're going to have a 1 left. So to get our two solutions, we have to set that equal to 0 and set that equal to 0. So x equals 0, that's one of them. And then 1/9 x minus 1 equals 0. So you would add 1 and times by 9 here. Okay, so then times by 9, times by 9. So we get x equals 9 for our second answer. Okay, so those are the two solutions for that problem. And if you check it, it will work. Last two problems, they are rational functions. So 23, we want to factor when we see those trinomials like that. So factor the denominator here. Okay, on the left, we're going to have x minus 4, x plus 3. On the right, we're going to have x minus 4, x plus 2. So to get common denominators, we have an x minus 4 in both of them. That's good. Over here, we need an x plus 3. Okay, top and bottom. And then on the left, we're going to have an x plus 2. Okay? And then we can just work on the top and keep that denominator there in the end. So here, we're going to get 5x squared plus 10x. And then we're going to have a minus, so we can kind of take this into this right now. So it's negative 3x minus 5. Foil that out with the x plus 3. So it'll be negative 3x squared minus 9x minus 5x minus 15. Simplify that down, and that is our numerator. That's the top. Okay, I missed that 3x squared right there. So 5x squared minus 3x squared is 2x squared. And then we have a 10x minus 9x, that's 1x. Minus 5x is a minus 4x. And then we have minus 15 on the back end. And we have to put that all over our common denominator, which is x minus 4, x plus 2, and x plus 3. That would be our solution. You can try to factor that top there. I don't think it does, but you always want to check that. Just for this problem, I don't think it does. Okay, so 24, multiplying those. The top here we can factor, so take a 4 out, you get x plus y. Bottom, you can't do anything. That's just a monomial. You don't factor monomials, they just stay as they are. So then these over here, the terms right here, y cubed over 12x, those are both monomials, so they don't factor at all either. So then we want to simplify any numbers that we can cross cancel, which would be the 4 and the 12, so that would turn into a 3 down there. And let's multiply straight across. Actually, we have this that we can cancel also. We can cancel a y. So that would give me a y squared. Now we can go straight across. Okay, so we're going to have y squared times x plus y over, we're going to have a 3x cubed down there. And we have that x there, and we got an x squared there, so we'll have a 3x cubed. That would be it. Okay, so that would be multiplying rational expressions. So hopefully as this video helped you out a little bit, if you got any questions other than this, send me an email. Good luck.